Okay.
It's like it's opposite because of this way that they're writing it. Okay, so I guess if you're asking, I believe the answer is 3 for that. And since you got access there, I'd recommend you enter these in, or if you really want me to, I can. Okay, question 8 is really similar. I assume we're doing that one next.
Hold on, quick question.
Yeah.
So I didn't really read the question. I was just looking at the table, but so it says, what is the change in 4x when y moves to
X4.
x4?
Yeah, they're saying to look at this column.
Oh, okay.
You don't even care about that one. And
Then
like,
why'd they throw in when y moves from 8 to 6?
Because you have to know which 2 rows to look at.
Oh, okay.
Like let's say it said for y went from 2 to
4.
Oh,
so you know to look at 10 and 13.
Yes, exactly.
Okay.
Exactly. Yeah. Sorry, we'll go through this slower. I thought you'd already looked at this one.
No, I just like rushed from work because I got stuck working on a job.
Oh,
So
that's good.
all over the place.
Work is good. Okay. So here's number 8. All right, so this one says if x3 moves from 8 to 12. So you look at x3, 8 to 12. Okay. What is the new value of y?
4.
Right. Well, it start, you have to look at it as a start and a stop. So the start is 4. The stop is 6. So from like from is where you're starting from, stop is where you're going to, and they're really asking what is the new value of y at x3 equals 12. But they're not saying that explicitly. And again, this column doesn't matter. It's just extra information. So x3 moves from 8 to 12. Okay, it like you got to think of it as an arrow. 8 went to 12, so y went from 4 to 6. And they're just asking for that new value of y, which is whatever the y value is there, 6. Is that clear, or do you want one like this?
Yeah, I get it.
You get it? Okay. Because we probably can always do one like these. Do we need to do question 9?
Let me see. I can't see 9.
Okay, so you don't have this up on your screen. All right, let me snip it in. You can tell me if you've already answered. That's why I'm asking. I'm trying to
okay.
Decide if you want us to do it or not.
Yeah, could we do that one?
Sure.
Because my buddy helped me with that one in class.
All right, so it says you went to have lunch with your friends and the total bill was $250. Wow, that's a lot. Your meal was $75. What percentage of the total cost was your bill? So a percentage, very simply put, is part over whole. The whole bill is how much? How much is the whole bill? I'm asking you.
Oh, sorry, 250.
250. And what was your part of it?
75.
75. Okay, so then if you got a calculator out, you just confirm that it is 30%. That looks pretty much on track. Yeah. So you gotta be careful with these radio buttons, or I'm sorry, the check boxes that is only one. So like down here. Okay, so this is one of those. So it says what percentage? This is the only percent. 0.3 is correct, but it's not a percentage. So what's unclear to me, and I don't know if, I mean, this might be one of those where you want to email your instructor. Like the question is saying what percentage? So I feel like 30% is the only answer, but 0.3 as a percent is, you multiply by 100 and you get 30.
Okay, sorry. Oh yeah, yeah.
All right, so what I'm saying is like, I think that this is the only answer, but then I wonder, well, why are there all these check boxes? I'm really tempted to like say to check this one also. Because, but this is one of those where if you had a question, if you had time, you could ask the teacher and say, you know, hey, I'm looking at this question. It says percentage. I know that that's 30%. 0.3 is also 30%, but it's not being asked.
Oh, you can click both.
Right, but I don't know if that's what they want here. Like I'm trying to stress to you, like I don't know what the intention was. I think that more than one, because it's a check. Go ahead.
Her syllabus questions were kind of trick questions too, which was weird.
Good
But
to know. So I think you need to check both.
okay. And it has the box where you can check both. Because like the ones with the circles, you can only check
Right,
one.
right. Now, do you want me to fill these out as we go? I haven't put any
Oh, I was
answers.
doing it.
Here. Oh, you're doing it? Okay.
8 is 6 and 7 is 3, right?
Yeah. Yes. Yes.
Mhm.
Okay. So move on to 10 now. Does that work?
Yeah.
Yeah, I think I know, or remember this instructor, kind of the other students, kind of the same thing here. All right, so you've got a system of equations. I'm going to write them nicely. Y equals 2x plus 1, and then x equals 7 minus 2y. There are a couple of approaches to solving a system of equations. Because it's solved for x already here, you want to use substitution.
Okay.
So you're going to take everything that x equals, which is 7 minus 2y, and you're going to write it in for x. So I'm going to do that down here. So it's y equals 2 parentheses 7 minus 2y plus 1. You literally take that, you shove it in for x, and then you have one variable left.
Okay.
All right, so to solve for y here, we're going to distribute this 2 to both terms. 2 times 7 is 14. 2 times negative 2y is minus 4y plus 1. Add 4y to both sides. On the left, you get 5y equals 14 plus 1. Combine like terms. Divide by 5. So y equals 3. This is not what the question is asking for, though. It's asking for the value of x. So this is not the right answer. This is the intermediate answer. So you have to recognize that, to say, okay, what am I actually being asked? And it's for the value of x. So to find x, you use this y value and you go back to this
And plug it
line.
back in.
Exactly. 7 minus 2 times 3 is 7 minus 6, or 1. Very easy to put the wrong answer.
So 1 would be x then.
Yes.
Okay.
Any questions on that?
I think that's good.
Okay, next question here. Okay, when two variables have a positive relationship. So here's what that means.
What
It
are you
means,
writing on?
so this is a WACOM. I believe it's pronounced Wacom. It's a tablet. It's
You use
actually,
a pen?
yeah,
Oh, no.
artists. So the artists like using this. I've tried I've got an iPad, but I don't like it as much. I've also tried a Surface Pro. This one works the best for
Oh,
me.
nice.
But everyone's a little different. It's not portable though. It's like I gotta be next to the computer with a power
Oh,
source. Like it's not,
yeah.
but it
It's
works really
cool
well for
though.
this. Yeah. And like I said, I'll send you these notes at the end, and we're screen recording this screen, so you're gonna be able to see this later on. And I'm intentionally not putting the problem numbers in there so that there's no issues, down the road. But positive relationship. So positive relationship is like the more of one thing happens, the more the other happens. Okay, and we can think of some examples like the hotter it is in Arizona, the more your air conditioning bill is. The faster you drive, the more gasoline you use. Okay, so they do tend to move in the same direction. So that means they both go up or they both go down. These next two refer to a negative relationship. So they're not the right answer.
Even if it remains constant, it's negative.
Well, yeah, good point. Probably not. I guess that's not what you need. The third one is for sure.
Okay.
Good catch on that. I didn't read it all.
But,
This one's negative. This would be no relationship. So these are like questions that they would ask on the test. Like there's like
Mhm.
someone else in this class probably got one that said two variables have a negative relationship, and it's this answer down here. So you could be asked any of these.
Yeah.
So I believe that is the best choice there. Any questions on that?
That's all.
Okay. So let's go to number 12 here. Go to the next one.
So it'd be they tend to move in the same direction then.
Yes. Yes.
I get that because
Yeah, and it goes the other way. It's like the less partying I do, well, that's not a good example. You got to think of two things that go down, like
that you
the
could do that one without like you could do that one by just reading the questions, really, huh?
yes.
Okay.
Okay, let's look at number 12 here. It says if the equation of the line is y equals 630 minus 3x, then the value of x when y is 0. So you're putting 0 in for x. I'm
Mhm.
sorry, in for y. Wow, I'm really off my game today. 0 in for y. You got to know which one it is. 0 in for y or 0 in for x. It tells you y equals 0.
Uh-huh.
So you are now solving for x. Okay. So you add 3x to both sides. 3x equals 630.
Mhm.
Divide by 3. X equals 210.
And sorry,
That's what it's looking for.
you
That's
you
for the
got that
value of x.
from 360 divided by 3.
Yes.
Okay.
And you're welcome to check, but it's pretty straightforward.
Sweet. Thank you.
Yeah. Now it could be the other way. They could say, the value of y when x is 0, and you got to put 0 in for x.
Hmm.
So it depends on the problem. All right, next question's got a graph of some sort. So we'll look at that. It says the graph above shows two lines, W and V. The numbers on the y-axis and x-axis are represented by letters. There are also areas in the graph also represented by letters. Okay, so far nothing new. Using the graph above, identify line W using W. Identify line W using line W when y equals m. Okay, so our focus, this is really weird. Focus is just on this line right here.
Hmm.
Just on that one. Sometimes it's better to go ahead and like make it a different color, just so you're like, that's what I'm looking at. When y is equal to m, okay, so they're saying there is m, and that's the y value right there. They want to know what is the value of x.
Okay.
So you have to identify this curve. Y is m. They're saying m is on the y value. Think of this as like 2, 3, and 4. When y is 2, what is the value of x? And think of this as like 2 and 3. Well, it's this
Okay.
value down here. It's r.
Okay.
It's just asking where you hit the curve. Okay, where do you hit the curve? And they're just making it complicated by using letters instead of numbers. That's why sometimes it's good to use numbers if you're really unsure.
Okay.
Is that clear? Or do you want another example of this?
Let me see. Sorry, I was just looking at it. You just use 2, 3, and 4 as just random numbers, right?
Yeah, just something to help differentiate, because we're
Yeah.
so comfortable with numbers as opposed to letters.
I guess it couldn't be M because there's no M for an answer, huh?
Yeah, it's basically just asking you for the ordered pair right there. It's like, what is the
Yeah.
ordered pair there? And the ordered pair is R comma M, which is weird because it's letters,
Yeah.
and R is the X value, M is the Y value.
Okay. Yeah, I see it now.
All right, let's go on to number 14.
14 is like the ones that we did.
Yeah, this time they're asking you to do some graphing here. So
Mhm.
it says if we graph Y and X4, so that's where you want to get rid of all this other stuff.
Yeah.
I mean, if you print out these lessons, it's good to just cross things out. And so we're gonna make a quick sketch of these ordered pairs. Now, I would tell you to rewrite them in the X comma Y format. So 18 comma 2, because X comes before Y,
Mhm.
16 comma 4, 14 comma 6, and then 12 comma 8.
Okay.
All right, and then we graph them. So 18.2 we'll call there, 16.4 there, 14.6 there, and 12.8 there. So it looks like a line like this.
Yeah.
Okay, and that's why it's so important to graph it properly, because if you mix them up, you might get a different graph. Right.
Yeah.
So in this one, what is the direction of the slope? Is it positive or negative?
Well, which way is it going?
So it's going down and to the right. Are you seeing my screen?
Yeah.
Okay, just making sure here.
Sorry.
Okay, so the slope is going down and to the right. That's negative.
Yeah.
Okay. When it goes up and to the right, that's
That's
positive.
positive.
Okay. And we saw that in that earlier problem where I'll just scroll up here for that. This is positive slope.
Uh-huh.
Positive slope and a positive relationship. Okay, so the answer is positive slope.
All right.
All right, question 15, going back to that graph again.
Mhm.
Looks more complicated than it actually is. So I teach this strategy, and it really does help here, is to go to the actual question. The question, like, don't read the other stuff unless you have to. It's using the graph above, the area represented by B. It's like, where is B? So let me go find B and shade that in. B is this rectangle here.
Yeah.
Okay. And a rectangle, the area of a rectangle is base times height.
Mhm.
Okay. The base is down here. The base is whatever this yellow is.
Uh-huh.
Okay. Do you agree with that?
Yeah. I think
So
I know.
okay. Which one are
Um,
you thinking?
it would be KL and then R.
Yeah, so it's K minus L. And the reason is like, let's say K is 10 and L is 8. We want the difference in height, and that's why you subtract the two. So yes, that's the correct answer.
Okay.
In this class, you're going to be calculating some of these areas, but for now, you just need to know the formula. All right, question 16. Move on to that. Are you allowed to use a calculator in this class?
I believe so.
And do you have a calculator besides what's on your phone?
Yes.
Okay. If it were me, I would try seeing
I
if
have
you.
like a little regular because last year they wouldn't let us use like a graphing one, so we just use like a little regular one.
Okay. Yeah, I mean, I'd like, for me, I want to know if you can calculate this or if you need some help in how to do it.
Okay.
Can you try calculating A up here? Just give me the final answer.
Yeah. I have my phone one with me. Is that okay?
Yeah, it doesn't matter to me. It's the idea is, though, is you want to practice. So that's a question for your instructors. Like, what kind of calculator am I allowed to use? It's
Mhm.
probably in the syllabus. But the reason you want to be so careful here is it's easy to make a mistake
Uh-huh.
entering this into the calculator. Right, so I'll throw this in the chat here. I like using, like when I'm just doing problems with students, I like this scientific calculator from Desmos. It's very intuitive to use. So consider taking a look at that. When you type it into the calculator, it looks the way you expect. So I'll show you that down here as well. So you should have gotten 0.4 or 2/5, either one.
Okay. So to calculate A, you
So this is where I need to know if you want us to go through this, how to do it by hand.
no, I can use a calculator, but
Okay.
would I do like 6 minus 4 times like
2, yeah, you actually do it times 2.
yeah.
It's because you multiply by the reciprocal. And then you divide by the 10. So it ends up being, like you said, 2 times 2 over 10, 4 over 10, which is 2/5.
Okay. So 2/5 is your answer then.
Yeah, or 0.4. But that's only part A. We got to do the same thing for part B.
Uh-huh.
We can do this by hand. 50 minus 30, do that part there. 50 minus 30 is 20.
Mm-hmm.
You're going to multiply by the 2 on the bottom. Over 50 plus 30 is 80. So it's 40 over 80 or 1/2.
That's 20 times 2, correct?
Yes.
Yeah.
Yes.
All right.
Okay, so that's 0.5 or if you if you prefer the fractions, it really doesn't matter. But then you got to take your answer from A
Uh-huh.
and divide it by B. So it's A. Actually, you can tell your instructor this is a mistake there. It should just say compute A divided by B.
Okay.
So but A is 0.4, B is 0.5. And when you have 2 decimals like this, you can multiply them both by 10, and that's 4/5.
And then you can, okay.
Or you go to a calculator. I don't really know how these are supposed to be taken. Like the other classes, sometimes they tell you like to write as a decimal, rounded to 1 decimal place. This one doesn't say.
Uh-huh.
But I think you can get away with typing in 0.8, 0.8.
It says only numerical values are accepted. I don't know what.
Yeah, I don't know what that means either. Like on my side, I can type in 0.8. So I think it'll accept that.
I'll just do that.
And I'm not when I'm done, I just close out. I don't ever submit anything unless you tell me to. Okay, 17. Are you ready? We move on to 17.
I'm ready.
All right. This could be the hardest problem. It's kind of awkward. Again, you go to, sorry about that. You go to what I call the call to action. It says like, this is the thing that it wants you to find. It wants you to find the area of C and E.
Uh-huh.
Okay, so one of the ways to do it is to find the area, but the problem is like they're using all these letters. So you have to like interpret what this means. So if we were to bump it up on its side,
Mhm.
where this is C and this is E, this right here is the base of the triangle.
Yeah.
So your base, I'm going to show it in red here. Your base is right here.
Would it
And
be that? Okay, sorry. You can
I
go.
was just going to ask you, I was going to ask you what 2 letters that refers to. I think you're
K
about
and
to,
M.
yeah. So that pretty much tells you it's that one.
Yeah.
Because that's the only K minus M, but we might as well keep going here. The
Okay.
height is going the other direction here. It's a little awkward. There's your height.
Mm-hmm.
There's your height. And that's S minus R. That's consistent with this first answer.
What is the little star in between for?
Just multiplication.
Okay. And the 2.
So you always divide your area by 2 in a triangle.
Okay.
And you're going to be doing that a bit in this class. The area of a triangle is 1/2 base times height, or like you're seeing here, base times height divided by 2.
Okay.
All right, number 18.
Mhm.
This is one of those brutal which of the following types of questions because I got a ton of multiple choice here. Just got a slight delay on my screen. Here we go. So we have to look at all the answers, unfortunately. Okay. So we are given this equation. It's good if you can graph it real quick or at least have an idea of what the graph looks like. So if you go to like Desmos and graph it, you'll find that it's 390 up here and then 130 comma 0 here. So it's some sort of downward shaping thing.
Uh-huh.
Okay. Is the slope positive or negative?
Negative.
It's negative. So the slope is positive. No, that's wrong.
Uh-huh.
The slope is -3. The slope is the number in front of x. That's true.
Okay.
When x is 0, y is 390. So you're putting 0 in for x, and that is this ordered pair here. So a couple ways to do it. You could write 390 minus 3 times 0, and you'll find that that's 390.
Mm-hmm.
Or you go to the graph and you realize like that's x and then y. So x is 0, y is 390. For the other one, it's now 0 equals 390 minus 3x. And if you solve that for x, you do indeed find that x is 130. And that's this point down here on the right. 3 times 130 is 390. 390 minus 390 works. Okay, so let's look at the rest here. The relationship between x and y is horizontal. Well, if you have a graph, it's not horizontal.
Yeah.
So that one's not correct. That one's not correct. The relationship between x and y is vertical. Well, it's not vertical, it's
No.
down. Okay. As x goes up, y goes down. So that means as you go to the right,
Yeah.
y goes down. And is that the case?
Yeah.
Yeah, downward sloping or negative relationship. Yeah, it's often the case in these like, check marks that there's more than one. That kind of supports that multiple answer in the previous one.
So should I check all of those then?
No. Yeah, these four. I'm sorry, just the ones with the
Yeah.
check marks.
Okay.
Okay,
Right.
so let's look at 19. I'm not going to drop in the multiple choice because it's a little overwhelming to start out.
Mm-hmm.
Sometimes they make these so hard to even just start. So you need to create a graph for each of these. So
Okay.
like think of graph 1 as being x1 and y, graph 2 x2 and y, graph 3 is x3 and y.
Okay.
All right, so now you just try and graph these as best you can. If you need to, you can like remake the ordered pairs. Like x, when you're looking at these two columns, your ordered pairs are 1, 2, 4, 4, 7, 6, 9, 8. So it's really confusing when y is there. So another strategy that I like is to actually move y over here,
Mm-hmm.
and then it's a little bit easier to sort of digest because you're used to going left to right.
Yeah.
So it's like, okay, 1, 2, 1, 2 is there, 4, 4 is there, 7, 6 is there, 9, 8 is there. So that to me looks positive, roughly.
Yeah.
All right, so the next one here is
So the key to knowing these is putting y before the x's.
the after. I mean the y value is
Oh, yeah,
the second
sorry.
value. Yeah, it's the second value in the ordered pair.
Yeah.
So for the next one here, your ordered pairs are 3, 2, and then 4, 4, 5, 6, and then 4, 8.
Okay.
So 3, 2, 4, 4, 5, 6, 4, 8. That one's a little wonky. It does kind of have an up relationship. It's not great.
Uh-huh. If you were taking a test, would you graph all these out?
Yeah, that's always a good idea.
Yeah.
So for the last one here, this is x1, x2. For the last one here, it's 4, 2. You're looking at that x3 value and then that y value.
Mm-hmm.
8, 4, 12, 6, and 16, 8. So 4, 2, 8, 4, 12, 6. So this one for sure has an upward positive relationship.
Mm-hmm.
So I would generally say that these
X,
all
Y.
have an upward relationship.
Yeah.
It's the the answer is all in x1
2 and 3.
and 3.
Okay.
And notice, like, I'm not graphing these very accurately. I'm just sort of like eyeballing it. I mean, and I do this
Yeah.
all the time, so it's easy for me, but the point is they're roughly in the right place
Yeah.
and you can deduce. It's like when you're out on a motorcycle, you know whether you're going uphill or downhill. Like, you don't need to get out and observe the landscape. You just know. And you just kind of get a feel for that as you do graph some points.
You could also use how you put Y at the end of all of them at the top left. You could just see if the first number's smaller too, right?
Well, these all go up. These all go up, and so do these.
Or
So,
sorry, if the
yeah, I mean, it's kind
the
of what
le-
you're saying. Yeah. Yeah,
if
like whatever you just said there, that makes sense to you, and that's right. Like, these numbers go up, and that's why it's growing each time.
sorry. Sorry, my allergies.
Yeah, they're bad here. They're very bad.
I
Okay,
understand that though.
okay. Here we go here. Last problem, at least for this set. So use the table to graph this information, and then they want the slope. So there is a formula for slope. You've learned this, learned it in high school, you saw it again in college. It's this one right here.
Mhm.
You have to be very careful with how you label it though. So this table is deceptive. Like, they're trying to not do it the way you should do it. So it's good to write the ordered pairs. 0, 63, x comes before y. And then the other ordered pair is 21, 0. It's always x and then y.
Mhm.
And then if you need to, you write x1, y1, x2, y2. And then you put those numbers into this formula.
Yeah.
So y2 is 0, y1 is 63, x2 is 21, x1 is 0. So you get negative 63 over 21, and that reduces to negative 3.
-3. Okay. And then you just take the sign from the bigger number to get your
Yeah,
negative.
yeah, because it's a negative over a positive, it's always
Yeah.
negative. And that kind of stuff will matter. You can see both answers are here.
Uh-huh.
This is big boy, stuff where they're not going to just give you the answer by, oh, I found negative 3, it's the only one. So just be careful here. I'm actually surprised they didn't have 1/3 in here, doing it the other way.
Mhm.
Right. So we got that done. My lessons are 50 minutes, so we've got about 5, 6 more minutes if you need it. You want something else to work on.
I think that's all I really need. But
Okay, sounds good. So I get extremely busy, from our first meeting. I mean, I'm really starting to get stacked. So the more in advance you give me your availability, or more in advance you ask for lessons, the better I'm able to help
okay.
you.